Okay, here is a look at solids, liquids, and gases and the intermolecular forces that are involved. When things are a gas, there are no intermolecular forces. They're so far apart that they do not interact on an intermolecular level, meaning between molecules. They can collide, but the models that are used don't involve any attractive forces, just plain old collisions like three-dimensional billiard balls. There's lots of freedom of motion. As you cool this stuff or compress it, it will liquefy and intermolecular forces will eventually come into play. If they're strong intermolecular forces, this will occur at a relatively high temperature, meaning it will stay a liquid up until a high temperature when you finally can break those intermolecular forces to boil this stuff. So that means that you can have a flow between the molecules and intermolecular forces, but they do play a role. Once you cool them down even more, things become static. You have an ordered arrangement. The particles are essentially in fixed positions. They're close together, and intermolecular forces are what's responsible for the shape of this molecule, and it tends to hold that very closely. Oh God, I hate that. The average kinetic energy of the gas molecules is much larger than the average energy of attractions between them, so they're moving around a lot, and there's hardly any attractive forces. The intermolecular forces play a role when you have liquids. They're strong enough to hold the moleculars close together, but without much order. They can flow around. Finally, now when you have solids, the attractive forces are strong enough to lock them in place. That's a quick look at solids, liquids, and gases and intermolecular forces.